Hi, in this video I will show you how to use lookup constraint in KineFX on this piston example. First up, I recommend watching KineFX Masterclass by the one and only Mr. Jeff Wagner. It says Masterclass, but don't be scared. Mr. Wagner explains it beautifully, so you will get a solid foundation on KineFX. Link is in the description. Also, I created this example so that in the end I attach the controls to objects in the object level, so you can control it from there. But I will show you why this might not be a good idea. Good, so let's see how this works. So here's the main object, the piston, the model, and the setup, the rig. So this is where the magic happens. This is just a null. It's for visualization only, so that doesn't do much. And these three are the controls which you can use to control the objects in the object level. Now let's dive inside and see what we got here. So this is the overview of this object, and in here I divided it into these parts. In this part, this is the object setup. Here in here you can set up all the materials and everything you need with the geometry. In here we got the creation of the skeleton. In this rectangle we have the skinning. This part is just attaching the nulls for visualization, so just a cosmetic feature, nothing important. In here we have the most important parts of this tutorial, which are the constraints, the look at constraints. And in here, in the final part, we have a bone deform. So when we move our skeleton, the geometry deforms with it. Good, so let's go through this in a more detail. So in here I'm importing geometry. I'm applying some materials from the material palette. Nothing too fancy, just basic materials. I'm using because I've set up my model properly in Blender, I'm using this attribute, this path name. So with this I'm setting up the materials. Now this will be important for the skinning, this group. As you can see, I put this piston base group, and I put primitives in this base primitives in this group, and this one is for the top part. So this is piston top group. Also I used this path attribute for this, so I don't have to select them manually. And maybe I could have done this with points, but maybe not. So this is why I'm promoting these groups. So I change it from primitives to points. Here you can see they are in the primitive groups, and in here they are as point groups. So that's for the geometry setup. Now let's continue with skeleton creation. There are multiple ways you can do this. I tried to go a little bit procedural. So what I did was I just blasted everything except these rings at the base and the top of the piston. So now actually let me turn off these guys, they're just distracting. And what I wanted to do is I fuse them together, and now I have just one point but many primitives, which I don't want. And maybe if you want to copy the settings, these are my settings, and I just used the dissolve to get rid of the primitives, so I'm left with only one point, which is what I want. Just this one point. Maybe I could have also used this add node and just create one point and move it into position, but I decided to go this semi procedural way. So I did this also for the top part. So I'm left with 2 points, and I have assigned a name attribute to it. So I named it base root. As you can see, this one is at the base, that's why it's called base root, and this one is at the top, that's top root. And I created another one by transforming it up, and this will be my up vector. This will be the bone for up vector. So I just merge them all together, and I use a rig doctor to initialize the transforms. Now, because I used these nodes to assign name attribute to my joints or bones, I don't have to use this initialize missing names. Otherwise, you might need to do it like this. If you don't give names to your bones, just click this and it will automatically fill some name for you. So because later the rigs will need this attribute and they cannot function without it, so you need this attribute. So this is just a handy tool to make it quick. And that's all for the skeleton setup. Good, let's continue with the skinning. I assigned a name attribute to the points for geometry so that Houdini is happy and it has this attribute on all the points. And I used this capture proximity to initialize the skinning weights, and then I used this capture override to override the skinning weights. So it works like this. I used the group I created previously in here at my geometry, and I'm assigning full weight 1 to bone base root. So you can select it here, and this will assign full weight to this bone. So I'm doing the same for the top root. Weight 1, top root, and I'm using this group I created previously. And that's all you need to do for the skinning. Now this part is only a cosmetic feature. So if you want to visualize your bones, you want to have some controllers attached to it, you can do it like this. You'll just this is the null I created in the object level. So I'm just merging it in, and I'm transforming it. As you can see, I'm making it a little bit smaller. And in here I'm assigning again a name attribute to it, because that's what Houdini needs to be happy. And in here, okay, let me just hide this. And in here I'm attaching this null to all of my bones joints. You can do that easily like this. Press enter, and it will be attached only to these two, or you can select it like this. It's up to you, but it's just a cosmetic feature. Good, so now we prepared our skinning, we have our geometry, our rig. Now let's move to animating and creating constraints. To animate your bones and geometry, you can use the rig pose. So it will look something like this. And you just need to go into this tool, and if you click it, you'll get all the joints in here and all their parameters. And I already locked some parameters before, so that's why some of mine are grayed out. and I did also some other settings which I'll show you later. But to create the constraints, so you have your joints, and now let's create some constraints for them. I'll go inside. Now how this works is in this part we're getting the joint attributes, their position and location and rotation, and in here we are writing out this data. And to get this quickly, you could either like type in get point transform and set it all up, or the quick way is, if you're in this tool, you can just click on it and the 2 dots will appear, and you can just left click and drag on the bottom one, and this will be like the set point transform. So this will be write out the data, and the top one is get. So in this will input all the data from that point. So you can just work with it and connect it with all the other nodes. And for the lookat, I'm using this lookat node, and in here I have my base root, this top root, and this up node, upper joint. And to connect it correctly, for the base root, what I did was I connected the base root to this from, because we're getting the basic data from this node. We want to look it to this top root, which is this node. So that's why this is in this X form is connected to this 2. Also the X form connected to from, and the up is connected to the up. And we will write out the transform to again to the base. So base in, base out. Looking at top, and the up vector is the up joint. And now this one is for the top root. So top root goes to from, and this top root needs to look at this base root. So that's why this 2 is connected to base root, and this up is again connected to up, and it goes to top root. Output is to top root set. And if you've seen my previous tutorial on how to do it the classic way with bones and just not in KineFX, you'll notice in here we have only 3 bones, and these 2 are, this one is just the up vector, and these 2 are looking at each other. And in the previous one we had to have 1 extra bone, because these 2 bones couldn't look at it, couldn't have a look at constraint at each other, because that created some infinite loop. But as you can see it works in KineFX. It works without issues. So that's a nice thing, that we have 1 less bone. Alright, and let me just hit play. So now the piston works correctly. And if I would disable this, you'll see this is without the constraints, the lookat constraints. And now all you need to do is connect the skin geometry to the first input, the rest pose to the second input, and the animated rig to the third input, and you'll have your animated piston. Now let me show you how I connected these 3 nulls to my joints. So first you'll just create a standard null, and the thing is that you need to go somewhere in here. And what I did was, first I aligned I turned on point snapping and snapped it to each of these nulls, and then you need to clean transform. And what I did was I copied the parameter and paste it. So this one is for the up, so I would just paste relative references in here. This is how it looks like. And then I could just control it with these objects. Well, let me show you what the issue is. So for example, I have this base root and this up control, and in general I would probably want them to be connected, parented together. So okay, this is not a problem because I can just clean the transform. But now, for example, I need to rotate this one, so I want to have them connected like this. And maybe I would even connect parent this to the top, who knows. But I want these two to be together. And okay, so now I rotated it, and this up piston moved, obviously moved. But in the translate, nothing has changed because of the parent, and it doesn't write out data in here. So now nothing can be transferred to here, to this up. That's why it stays in place. And if I would go to the final output, that's why there is no change in the up vector. But as soon as I move it, you can see it moves. So my issue is because the parenting doesn't change these values, you can use parenting, and which might not be very helpful, because in some case you want to have relationships between your control objects. So this is why I don't really like this method. So I'm not sure how other people deal with it, but if you know a quick and easy way to fix it, please let me know in the comments. I would love to hear that. So other than that, I hope in the next Houdini release we will get some note, something like this rig pose. You can just put it in here, and you can maybe just link these null objects in there, and it could work something like it would get the world space position of each and the rotation and scale of each of these nulls, and it would just translate it to the bones. You would have a connection between the null and the specified bone, and it would just copy and translate the world space position from the object level to this sub level. Anyway, thanks for watching. I hope this was helpful for you, and see you in the next one.